All right, hello everyone. We are about to begin basic math skills part 2. This is applied math, and we should be after this. The idea is after this lesson, we're through the basic math skills, the stuff that the book assumed you already had, the stuff that you might have missed in your pre-algebra, algebra 1 classes, the skills that you really need in order to do the stuff we're about to get into. And then next week we'll start doing a bit more. I guess it'll still be math, but it'll be just directly applied to the situations we're going to deal with. So this is the last lesson that's just purely feels like an algebra 1 class. All right, so let's get into it. Let me share my screen. Let's look at the PowerPoint for today. Okay, so applied math part 2. We're going to look at three things today. We're going to look at rounding will be the first thing. And then we're going to work on calculating averages. And then the last part, I've gotten a couple emails from you telling me that this has been some of y'all's weakness, and that is making calculations with fractions. Again, we're shooting for practical. And yes, a lot of the stuff that ministers count is money. You don't really need fractions for money, but fractions will come up because another practical thing will be making measurements. I mean, really, it's anybody who does, like, if you find a construction worker that does a lot of flooring, they're actually really good at fractions for measuring. So we'll need to get into a little bit of the fractions. So that'll be the end of the day. So let's look at rounding. What rounding does is it just takes problems and it simplifies them. So in order to make sure we're speaking the same language when it comes to rounding, we need to think about the name of each decimal place. So basically, if you look right here, starting at the decimal point, let's work going left. You just go up. So you call it the ones place, the tens place, the hundreds place, the thousands place. You could continue the 10,000s, the 100,000s, the millions. You basically just name the digit. I mean, it's pretty self-explanatory for that. Where people mix this up, though, is when you go to the right of the decimal and they want to call this first place like the oneths, and they want to call the next place the tenths. But actually, this first decimal place to the right of the decimal point, this place is called the tenths. Because right here, when you're saying, what do I have four of? I have 4 ones. I have 1, 2, 3, 4. But right here, when it says I have 5 what? Well, it's not once, because if you're putting that th at the end, you're saying a fraction of that. What this is 5 what's? It's 5 tenths. So if we take 10 and cut it, and we basically what it's saying is going in that decimal place, it's a fraction. So it makes it kind of weird that you're basically, what you're saying right here is tenths, even though right here it's 2 places over gets to the tens. In this, it's the first place is the tenths. So then the next place, and the same way that right here, your third place is the hundreds, and that means your second place is the hundredths. So if you can't hear what I'm saying, if it's not clear in the way I'm saying it, it's hundreds ending in S for the third decimal place going in the left direction, but going to the right, the second decimal place, we'll call that the hundredths. So then the next place is this thousandths, then the 10,000ths, then the 100,000ths, then you guessed it, the millionths, 10 millionths, 100 millionths, and like that. That's how it goes. Okay. So that way, when I say round this to the nearest hundredth, what you'll do is you'll basically go like this. You'll be like, okay, well, 100 place would be over 1, 2, 3. So the 100th place is just 1 to the left of that. Or if it's like the millionth, just think 10th, 100th, 1,000th, 10,000th, 100 million, 100,000th, millionth. So that's the first thing you need to understand with rounding. So when we say a place, we all know what we're talking about. So the way you're going to round is you're going to look to the right of whatever place it tells you to round to. And if the digit to the right is below 5, you keep the decimal place the way it is. If it's above 5, you will round up at the decimal place. And so what'll happen if it's exactly 5, you're going to round up. And the reason is because if it's 5, the chances that it's 5 and then every decimal place to infinity to the right is exactly 0, that's not going to happen. Somewhere something will at least be like a 1. So that's why at 5 you round up. Normally it's just going to be like 5 and then it's so if we're at a digit and the next digit over is a 5, right? Let's just do this. Like if we're going to round to this and this is a 1 and then this is a 5, then there's normally like a 3 or something like that. So you're like, okay, it's not just a flat 5, it's a 5-3. So that's obviously bigger than 5. And so what you would do is you would round this up to a 2. The one would round up to a 2. So that's why at 5 we're gonna round up, because we assume that 5 is above 5, because it's not just 5, it's 5-3. So if it's a decimal, it'll be 5.3, it could be 53, it could be a 500 with 30. So it's depending where it's at. There's always going to be something to the right of the 5, and we assume something comes eventually, even if it's not written there. So let's look at these. What's going to happen with each of these? Let's take 182.7365. And if you round to the hundreds place, that means we're going to take this. We look to the right of it. The first thing you see is an 8. Am I rounding up or am I rounding down? Well, at 8, I would round up. So what I'm going to do is turn this into a 2. But you don't just write 2. You need, because this goes from 182 up to 200. So what you will do, this gets into significant digits, which if you took high school chemistry, you probably don't miss that, which we're not going to get huge detail of significant digits. But what you'll need to do is write the 2 and then just write your 200, your 2 zeros as placeholders to say you're saying 200 and not 2. So if you round to the tens place, so that means go to the tens place and look what's there. So we have 1, 8. And so what's going to happen? What do I round this to? Do I round up to 190 or down to 180? Well, this is a 2 right here. So you round down and make it 180. What about the ones place? 182. What's to the right of the 2? It's 0.7. So round up, make it 183. Okay, what about one? Oh, hold on. There's a typo right here. All of these need to be fixed. This would be very confusing. What about the hundredths place? Actually, did I say the tenths place? I don't think I did. So tenths, we're going to keep the 7 and we round down. So 0.7, 182.7, because there's a 3 to the right of it. What about the hundredths place? It's going to be 182.74. So this right here, we're going to round up. And so 3/6 rounds up to a 4. And then what about the thousandths place? That'll be right here. So right here, it's a 6. To the right of it's a 5. And as I said, at 5, we would round up. Even though this thing didn't record what's to the right of the 5, you can just assume something in there will make it so it's not 5 flat. It's something a little above 5. So we'll say 737. Okay, so that's how we do that. So rounding, I hope, isn't super challenging. Most of you probably have had some experience with this. It just might have been a little while since you've seen it. So let's go ahead, take a second. I'm going to have you pause, and I'm going to have you work these 4 problems, and then press play and see how I do it. So go ahead and press pause, and then once you are ready to see how I do it, press play. All right, I'm assuming you've pressed play by now, and you're ready to see how I do it. So what I'm going to do before I unshare the screen, I'm going to write all these down. And all right. And we're going to the nearest 1. So what I'm going to do is I'm going to underline the ones place. So the nearest 1, and then the nearest hundredth. So 10th, 100th, the nearest 10th. So that'd be 10th, and then the nearest 100. So 1, 10, 100. So let's stop sharing so you can see. Okay, so we have 136.7, and so that's going to round to 136. Can you see that over there? Yeah. 10.0345. To the right of that's a 4, so we'll round down. So 10.03. 12.15823. We're keeping at the 10th place. So what we're going to do here is make it 12.2. And then right here, 1053.1. So what we're going to do right here is we're going to take that 53, we're going to round up. So it'll be 1,100. And that's what we get for that. Okay. So let's go back to sharing the screen. All right, so that's really it for rounding. So I don't think rounding is anything that should be super complicated. I think that's all we need for that. So let's look at averages. Averages is something extremely useful. It's going to come up in a lot of the stuff we do. It'll come up in budgeting. It'll come up in projecting things for churches. And so it's something that is useful for our future lessons and just real life ministry projects. If you're a sports fan, you're always thinking about averages. So to calculate an average, I mean, it comes up in this class. You want to calculate your average for school. So really averages are something that come up a lot. To calculate an average, what you do is you add up all of the data points and then you divide by how many data points you used. So for example, if you're looking, what's the average between 10 and 20? You'll add 10 plus 20 to get 30, and you use two data points. 10 was your first data point, 20 was your second. So you'll do the 30 for your total, and then since you use two numbers, you'll do 30, you'll divide by 2, you get to 15. And so think about what you're saying. If you have 10 and you have 20, well, what's the average? What you're saying is if I got the same amount every time, what would get me there? So for example, if it's like you scored 10 points today and then you scored 20 points yesterday and you say, what's my scoring average? You're meaning what's the amount that I could have scored each day to get the same amount? And since you had 10 and you had 20, it got to 30. If you just did 15 every single day, then that would be the same thing would happen. Averages are extremely important with churches projecting what's going to happen, projecting what kind of people to expect, what kind of income to expect. Averages will come up a lot. So let's use 10 and 20 and 30. So 10 and 20, and then let's say first day you score 10, second day you score 20, next day you score 30. What's your average across all three of them? So now look what you do. 10 plus 20 plus 30 equals 60. And now since we use 3 points, you'll do 60 divided by 3, and you'll get 20. So if you did 10, 20, 30, gets you to 60. If you just did 20 each of the 3 times, that would also get you to 60. So that's how average is find out what's the number that if it was that number every time, it would give me the same amount. So now look at this. Let's say what's the average attendance if over 5 Sundays, the attendance was 110, and then 82, and then 104, 114, and 108. So how many, if that's your average over 5 Sundays, how many can you expect on a normal Sunday? Or what's the amount of people that if that exact amount came every time, it would get us the same total? So how many data points do we have? We have 1, 2, 3, 4, 5. So what you'll do is you'll take all 5 of those numbers, you'll add them up. And then once you get your total, you'll divide it by 5. When you do it here, you end up with 103.6. Let me say a couple things. Number one, I'm totally okay if you use a calculator for this. You can use a calculator for this average stuff. When we get to the fractions, I don't want you to use a calculator to dodge the fractions, meaning some calculators, you can just plug it all in, it figures it out for you. And then others will allow you to just make it into a decimal. I don't want you doing that on the fractions. Maybe on the fractions, if there's a big number being added and divided, you could use a calculator for that step instead of doing it in your head. But be careful with calculators on fractions. I don't want you to use it to dodge the skill. But for averages, you could plug all this in the calculator. When we get to this section on tools, we'll get into some detail of the proper way to use a calculator. If you were doing this, you know your order of operations now. You have to put this all in parentheses in a calculator. Otherwise, order of operations, division comes first. So if you don't put a parenthesis on this, all the calculator sees is 108 divided by 5. It'll figure that out. Then it will add all this stuff and you'll have a massive number. So when you're using a calculator, make sure that you use your decimals or use your parentheses the right way. But what this is saying is that if 103.6 people came every Sunday, we would get the same amount as this random number. So what you might think is you're saying, but there's no such thing as 0.6 people. That's just what it takes to get to the same total. So out of those 5 days, obviously it's not saying that each day 103.6 people came. What it's saying is if 103.6 people came 4 or 5 days in a row, if that exact amount of people came, we would get the same total that this got us to. So basically what it's saying is you're getting about 103 to 104 people each day, somewhere in that range. Now, if for every day where it goes way above that, there's another day where it goes way above that. So it balances out to about the middle. So what that's useful for, if you're saying, okay, and I mean, look at it. Which one of these days was the closest to 103.6? There was a day where we had 104 people, but then all the other days it's all over the place. And so you're like, well, how can I predict that? And the thing is if you predict the low number of people to come every time, you're going to under budget things. And if you predict the high number of people, you're going to over budget. So that's why averages are helpful, because you say on average, I'm going to get 103.6 people. So on the days where you have more than 103.6, you can expect a few days with below so that it balances out. That allows you to buy the right materials for communion stuff. It allows you to have the right number of seats. It allows you can expect what kind of contributions to get, what kind of tithes and offerings. You know what I'm saying? Like you want to know how many to expect. And so this coming up with an average allows you to actually have a number to work with. So let's do these two examples. So I'm gonna pause. I want to let you work these examples. So try these yourself, see what your average is, and then once you try these yourself, then go ahead and press play and see me do them. All right, so I'm assuming by now you've tried them, you press play. You know what I'm actually gonna do? I'm going to I don't even think I need to write these down. So what I'm gonna do is I'm gonna pull these up on a calculator. I don't think you're gonna see the calculator because I'm just sharing the window. So I think the way that this works is you won't see my calculator because all I'm sharing is the PowerPoint. But yeah, I don't think, maybe I could do this. Maybe if I share, yeah, it won't let me. Okay, here we go. Control share. So I think now, yeah, there we go. Now you can see the calculator. Yeah, okay, good. Okay, so again, like I said, for this, I don't mind you using a calculator. Here's what I'm gonna do. I'm gonna do 1202 plus 2559 plus 1908 plus 2109. So our total over the 4 weeks, because it's 1, 2, 3, 4, our total is 7778. So then what's our average weekly giving? So we divide by 4. So we're averaging 1,944.5 each week. So if you look at it, let's see if that seems reasonable. So we're saying we're having 1944 on average. Okay, right here we're way below that. And then right here we're way above that. And then right here we're pretty close. And right here we're just barely above. So yeah, it seems like it's hovering around this. For every low day, there's a much higher day. So that's why 1944 is our average. Okay, what about, let's do annual income here. Church has an annual income of 23,450. So let's type that in. So let me clear what we had here. So we have 23,450. I mistyped that. 230,450. Okay, 230,450 plus 198,200 plus 201,904 plus 186,905 plus 202,010. I hope I didn't make any mistakes there because I was looking down at the numbers, but let me double check this. 230,450, good. 198,200, good. 201,904, 186,905, 202,010. Okay, so what we ended up with is over 6 years, we had 1,019,469. Let me double check. I said 6 years. Let me double check. It's 1, 2, 3, 4. Okay, it's 5 years. 1, 2, 3, 4, 5. So this is over 5 years. So we divide by 5 and we get 203,893.8. That's our average. And look at this. This is a little above, a little bit below, barely below, quite a bit below, and then very close. So we have 2 that are very close, 1 that's barely below, 1 that's a decent amount below, and then 1 that's a lot above. So these all together average out to that 203 figure we have. With something like this, we can get into this more later, but I would almost be nervous calculating 2 or 3 as your average here because of the fact you have one particular example that's bringing you way above. I mean, look at you're barely sticking around 200. So we'll get into talking about that if you have extreme outliers. That's what an outlier is one example that's bringing your average way up or way high. But anyways, here you would say your average is 2 or 3,893. All right, next up. So again, let's pause, press play, and then so I'm sorry, pause, try this yourself, see what you get, press play, double check what I did. All right. Okay, so I'm assuming you've done this yourself. So what's a player scores 25. Let me slide this down. So player scores 25. 25 plus 32 plus 27 plus 38 plus 28. So he scores 150 over 1, 2, 3, 4, 5 games. So divide by 5. He's averaging 30 a game. Yeah, that looks about right. Because look at your numbers. You have 28, 27, 32, very close to 30. 25, quite a bit below by 5. 38 is above by 8 to make up for these other two that were below. So yeah, 30 a game. That sounds about right. Next up, I think I actually, when I created this PowerPoint, I pulled this off of a statistic. This is interesting. I grew up in the San Francisco area, so I was curious. 48% of people in San Francisco claim to be Christian. 52% of people in Seattle claim to be Christian. 59% of people in New York claim to be Christian. What is the average percentage of Christians across the 3 cities? Okay, let me just say with this, if you were in some type of a data analysis class, which we're not going to go that deep with this, you would not just average these 3 straight across. You would figure out how many people are in each place, but we're not getting into all that. Let's just average the 3 numbers. 48%, 52%, 59%. So 159 out of 3 examples. So 53. So out of the 3 cities, on average, it's 53% Christian across the 3 cities. So that's how we do average. Okay, so average is something else that's a skill you need to have. It's something that you should have, that ideally you picked up in a previous class. Ideally, you've seen it before. It is something that is practical, that's used a lot in the real world. But so these are your examples for how to do averaging. And again, because it's kind of a simpler skill, I think this is all we need is these practice problems right here. Excuse me. So now we get into the good stuff, the stuff that I know some of you have been dreading. And now we're going to get into fractions. Drink my water, get ready for this. All right, so a lot of people hate fractions. I've taught 9th, 10th, 11th, 12th grade math and science. I'm obviously teaching a college level math class at this point. I've helped different people in different people. I've helped people that go on to become like nurses and doctors, former students. I have former students that went on to become engineers, that went further than I did in math. And fractions, they hated fractions. Like, it doesn't matter how far you go in math, fractions are something a lot of people hate. If you're telling me, some of you emailed me, said fractions were the thing you hated most, don't worry, you're not alone. A lot of people hate fractions. Hopefully what I can do is show you fractions in a way to make it not feel so bad. So we're gonna use fractions, and we're gonna talk about adding, subtracting, multiplying, and dividing fractions. So let's talk about if we're going to, let me just do a little thing on fractions. What fractions is let's talk about what the difference is between like between like 2/3 and let's do 2/4. Okay, so the thing here is that it's saying the number 2, and then it's saying out of how many slices of pie, basically. I like to always explain fractions early on and relate them to pie. So think about it. Would you rather have 2 slices of pie or 2 slices of pie? It's kind of like, well, duh, wouldn't it be the same? Well, no, not necessarily the same. It depends on who's cutting it. So if somebody cuts the pie, My pies are not the same size, which kind of messes things up, but just follow along. So if this person cuts the pie into thirds, okay, and this person cuts it into fourths. Now who do you want two slices of pie from? The one that cut it into thirds or the one that cut it into fourths? You probably want the one that cut it into thirds, right? Then the other thing is, what if we added those together? How many slices of pie would we have? You couldn't really say 4 slices of pie because it's confusing, because it's different sized slices. So if you get more of these, you can just add them together and it's no problem. But combining these slices with those slices, that's kind of confusing. It's like, well, there's you can't just say 4 slices, because is it 4 fourths or is it 4 thirds? What is it? So that's why we have to have a rule for fractions. Just picture taking these pieces and adding them to those. It's just, you can't say 4 total slices because it's different size slices. So what we're going to do with fractions, we're going to set up a system of rules. So first I'm going to talk about adding and subtracting, which is what the example I was just having us think about here. So for adding and subtracting, first what we do is we need to find a common denominator. Denominator is the number on the bottom. So if you're going to add slices, you can't do 2 thirds with 2 fourths. Thirds and fourths don't combine. What you need to do is decide what is a third and what does a fourth have in common. So if I'm gonna, let me go ahead and show you how I would. So what I'm gonna do with this is, let's take this and let's cut. See what I did is I cut twice as much. So instead of it being 2 thirds, it's now how many slices? 1, 2, 3, 4, 5, 6. Out of 6 slices, we have 4. I'm essentially doubling that. So what's 2 times 2? 4. What's 3 times 2? 6. Okay. And then, well, okay, let's do the same to this. Okay. So I doubled that. Actually, hold on. Let's not double this. Okay, no, let me take that back. I'm not going to go by doubling it. What I want you to think about, remember our original numbers were 3 and 4. So let's take a second, think about this. What is a number that both of those can multiply and become? What's the lowest number we can multiply those and they can turn into? Well, 3 and 4, if you do 3 times 4, they can both become 12. So let me actually start with that. So the number we want our bottom number to both become is 12. So if I double this, it's 4 out of 6. And then if I cut it again, so see, I've cut it again. I've cut it into 12 slices. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 out of 12 slices. Okay, so remember what we started with. We started with 2 thirds. But I turned that into 8 twelfths. And then what are we going to do with the 2 fourths? Well, if I need to turn 4 into 12. So if you take each of your slices and cut them into 3. So 1, 2. So that's 3 slices in there. That's 3 slices in there. That's 3 slices. And that's 3 slices. So each of my 4s, I cut into 3 slices. So I tripled everything I had here. So the 2 instead becomes 6. and the 4 instead becomes 12. So if you look at it, this is 1, 2, 3, 4, 5, and then this was still shaded 6. So this is 6 pieces. This is 8 pieces, and now they actually relate to each other because it's 8 out of 12 and 6 out of 12. When I say 8, I'm speaking the same language as when I say 6, because they're both the same kind of slices. So when you combine them, 8 out of 12 plus 6 out of 12, you can actually add them together, because when you add them together, you're going to get 14 out of 12. And what you're saying is that you have 14 total pieces when they're cut into 12 slices. That's what you're saying. So when you add or subtract, notice that you don't add or subtract the bottom number. You need to make it the same so that both are talking about the same thing, and you leave the bottom number the same, and you'll just add or subtract what's on top. So I hope that seeing it with the slices of pie kind of shows why it works the way it does. So with that, let's look at the actual rule. So you're going to find the common denominator, get a bottom number that's the same, make equivalent fractions using the new common denominator. That's what we did there. In the last example, we decided to make the bottom number 12 for both of them. And then whatever you multiplied by to turn the bottom number into 12, multiply the top number, the numerator by the same amount. So then what you do is you add or subtract the numerators, which is the numbers on top, and the denominator, the number on bottom, stays the same. And then the last step is you simplify or reduce. So in this example, the one thing I didn't do here when I end up with 14 over 12 is I didn't reduce this to divide 14 by 2 and it's 7, divide 12 by 2 and it's 6. So I can reduce that to 7 over 6. Okay, so that's the process we're going to go through. So let's look at some examples here. So let's do 3 over 8 plus 5 over 6. Okay, what's the least common denominator? What's the lowest number that 8 can turn into and 6 can turn into? So in the last example, when we had, what did we have? We had 3 and 4. We multiplied them together to make 12. In this case, 8 and 6, what can they both become? They can both become 24. 8 becomes 24 by doing what? By multiplying it by 3. So 8 times 3 is 24. And then what's 3 times 3? 9. So this first number, it's basically like if it was the slices of pie, we cut them into 8 slices and had 3. Well, you'd have to cut each of your 8 pieces 3 more times to make 24 pieces, which takes the 3 that you were allowed to take and cuts those into 3 pieces, and so you get 9. So 24 is our number we want. How does 6 turn into 24? Well, by multiplying by 4. 6 times 4 is 24. But then you got to do it to the top. And 5 times 4 is 20. And now you just have 9 over 24, 20 over 24, add them together. And with adding fractions, the 24, it's not adding 24 to 24. It's saying 24 is the number of pieces we've had all along. So nothing changes on bottom, it's just 24. All you're doing is on top, it's saying how many slices you had. 9 plus 20, we had 29 slices. So 3/8 plus 5/6 is 29 24ths. That's what it would come out to. Okay, 7 and 8/9 minus 3 and 2/3. So what about when we have a mixed fraction? It's not as bad as it may seem. What we're going to do is we're going to just ignore the whole number. So ignore the 7, ignore the 3, and let's get our fractions to end up being have the same number on bottom. So just look at the bottom. We have a 9, we have a 3. What do they have in common? Well, they can both become 9. For this one, don't change a thing. So it's just 8/9 still. For this one, multiply it by 3. 3 times 3 is 9. Up top, you have a 2. 2 times 3 is 6. So now you have 7. So it's that you have 7 whole pies. And then the other piece, you had 8/9 of a pie. And what the person ate was 3 whole pies and 6 slices when they were cut into 9s. So out of the 8 slices, you took away 6. So you have 2 left of the piece that was cut into 9s. And then of the whole pie, the 7 minus 3, you have 4 whole pies left. So basically, if it says like you had 7 whole pies, and then the other pie you cut it into nine slices, and you had 8 of those, and then a person comes along, they ate 3 whole pies. 7 minus 3, we have 4, and then of the piece cut into ninths, they ate 6 of those slices. So you just do 8 minus 6 and get 2. It would be 2 slices left when it was cut into 9 slices. So that's what it would look like. So that's how it works when we multiply or when we add or subtract. Now, multiplying fractions, I think, is way, way, way easier. What all you're going to do with this is you're going to change mixed numbers into improper fractions. So if you had something like this, the way you're going to make a mixed number into an improper fraction is, because this is saying I have 7 total pies. Well, what this 7 represents is 9 out of 9, 7 times. So what you're going to do to take a mixed number, so we're going to do it here. Notice this is the example coming up, is you'll do, if it's 4 1/5 and you need to make it into an improper fraction, do 4 times 5. And what's that? Well, that's 20, and then add that to the top number. So 4 1/5 is 20 1/5. The way you get that is do 5 times 4, that's 20, add it to the top, so the top is 21. So this is another example we'll have. Look at this. When you have 3 1/5, 3 times 5 is 15. Add it to the top. So you have 16 over 5. Okay, so we're going to make improper fractions, and then we're going to just multiply the numbers on bottom. We're going to multiply the numbers on top. So when you're multiplying fractions, that's where you can actually change what's on bottom. You don't just leave the bottom the same all the time. That's why multiplying and dividing fractions, in my opinion, is way easier, because you don't have to figure out how to have the same bottom number in the first step. And I think that's what mixes people up a lot with dealing with fractions, is they forget, like, well, when do I change the bottom number and when do I leave it the same? You have to have the same bottom number when you're adding and subtracting fractions. You don't care when you're multiplying and dividing. So, so you multiply the top, multiply the bottom, and then you can simplify. One thing about this is that it can help you if you simplify before doing any multiplication. So if you have a 2 over 4, make it a 1 over 2 before you do anything. I'll show you examples of that. And then with this one, with these ones, with multiplying, dividing, if it's improper, leave it as it is. Don't make it a mixed. So look at this. How do you do 3 over 8 times 5 over 6? Well, this is going to be fairly simple. We're just going to do 3 times 5 is 15. 8 times 6 is 48. But this can be reduced. So that's what's going on with this step. 15 can be reduced by what? Well, it can be reduced by 3. So if you divide by 3, it becomes 5. And then 48 can also be reduced by 3. So you do 48 divided by 3, it becomes 16. Let me actually show you a different way to do this. So let's get rid of all this. Let me show you an easy way to do this problem. If it's 3 over 8, what do we have? We had 3 over 8 times 5 over 6. Okay, remember, you can simplify before you do the multiplying. So you have 3 over 8. Can you reduce either of those? 3 over 8? No, 3 doesn't go into 8 at all. You have 5 over 6. Can that get reduced? No. But look at this. You see what I'm doing here? The 3 and the 6. You can reduce those. How many times does 3 go into 3? 1 time. How many times does 3 go into 6? 2 times. Now it's extremely easy. 1 times 5 is 5. 8 times 2 is 16. So that would have been the quick way. Let me get back to sharing screen. So that's the fast and easy way to get to what we had. How you you divided both sides by 3. You can just do it in the first step, noticing there's a 3 and a 6. Turn this into a 1, turn this into a 2. Either way, you get 5 out of 16. 4 1/5 times 10 over 11. Okay, so the problem here is that you need to take your mixed fractions and turn them into improper fractions. So 4 times 5 is 20. Add 20 to 1, you have 21 on top now. And then you just do 21 over 5 times 10 over 11. Okay, let's do this. So again, let's let me start from the top. We have 4 1/5 times 10 over 11. And so we're going to do 4 times 5 and make it 20 and add that to the top. So 21 over 5 times 10 over 11. And so you're like, oh man, I got to do 21 times 10 and I got to do 5 times 11. I might have these big numbers and I got to figure out how to reduce. Way easier. Do you see what you can reduce from the beginning? You have a 5 and you have a 10. What's 5 divided by 5? 1. What's 10 divided by 2? I'm sorry. 10 divided by 5. 2. So now you're just doing 21 times 2, which is 42. And then you're doing 1 times 11, which is 11. So that is the easy way to do it at the beginning. If you didn't do it my way, let's see how it turns out. So let's leave it as a 5. Let's leave it as a 10. How would this turn out? Well, this would be 55. And this would be 210. And then you'll say those numbers are both too big. And then you'll go, oh, you could divide both of those by 5. And then you'll go, well, what's 55 divided by 5? That's 11. And then you'll go, well, what's 210 divided by 5? And then you'll go, that's 42. And you're right back where you were, except for it's just easier to divide with smaller numbers before you multiply them and make them into bigger numbers. So that's why with multiplying and dividing, it's always best to reduce before you do any problems. Okay, did I not? I don't think I shared screen yet. Yeah, let's share screen. Share screen, PowerPoint. Okay. So going on to the next thing, dividing by fractions. I honestly don't think this is that bad either. If you can multiply by fractions, you can divide by fractions. Again, I think people just get intimidated by fractions. They assume it's harder than it is. But all you're going to do for this is you just flip the second number. Just flip it upside down. It's literally it. When it's a division problem, flip it and then turn it into a multiplication problem. So I'll go through this, what the PowerPoint says, but change mixed number into proper fractions like we did last time. So any whole numbers out front, multiply them by the bottom number, and then add them to the top. Now you're going to find the reciprocal for the second fraction. Reciprocal is fancy math word for take the fraction and flip it upside down. It is important that you turn mixed numbers into improper fractions first. So that way you don't have some random number in front. And if you flip and then deal with your number in front, you're going to mess things up. So, mixed number to improper fraction first, then flip the second one upside down, then multiply, and then simplify, just like before. So 3 over 8 divided by 5 over 6. So look what happened. You just change the multiplication and take that 5 over 6 and flip it to a 6 over 5. In this case, what they did is they did 3 times 6 to make 18. 8 times 5 to make 40. Divide the 18 by 2 to make it 9. Divide the 40 by 2 to make it 20. And then we're done. What I would have done is right here on this step, I would have seen that I have a 6 and I have an 8, and I would have made the 6 into a 3. So I would divide 6 by 2, make it 3. 3 times 3 is 9. And then because I divided 6 by 2, I would have divided 8 by 2 and make it a 4. I have 4 times 5 and I'd get a 20. So I would have just done this at this step right here. But either way, it gets you to the same thing. 3 1/5 divided by 10 over 11. So take 3 times 5 is 15. Take 15 plus 1 and you'll have a 16 over 5. And then we don't want to do division, so make it a multiplication and flip the 10 and 11 upside down. So it'll be 16 over 5 times 11 over 10. In this case, you could, so what they did is they reduced first. Actually, hold on a second. Okay, no, this isn't a slideshow that gives you more to it. Okay, so let me go ahead and let me just write this one. 16 over 5 times 11 over 10. So what I'm going to do with this, stop sharing. So 16 over 5 times 11 over 10. I'm going to turn this into 8. And I'm going to turn this into 5. So I divided that by 2, divided that by 2. And then 8 times 11 is 88. And then 5 times 5 is 25. So 88 over 25. And that's it. So dividing by fractions isn't that bad either, is it? You just take the second number, flip it upside down, and then multiply the top, multiply the bottom. And then remember adding, subtracting. You just leave the bottom numbers. You don't add them or subtract them, but you make them the same and then leave that in your answer, add or subtract the top. That's really it. Fractions are not as bad as I think a lot of people make them out to be. I hope that breaking down the difference in the different, like what you have to do for each one, I hope that helps ease some of the anxiety on these. So with that, let's do these 10 examples. All right, so press pause, go through these 10 examples, make sure that you're doing them right. And in the rest of the video, I will go through them and we'll make sure you're on the right track. All right, I'm assuming if you're here, you've already done these 10 problems yourself. So let's go ahead and go through them. So first one, 9 fifths minus 5/8. I'm just going to write these down and I'll see if I can do 5 at a time if I can fit them here. 7 over 6 minus 5 over 6. Negative 1/3 plus 3 over 8. 4. I'll do these 3 and then I just want to make sure I have enough room. Okay. 9 minus 5, 9 over 5 minus 8 over 5. In fact, I'm not even going to have the equal yet. I'm glad I only wrote 3 because I'm going to want some room for these. So what's the bottom number? What do we want on bottom? With a 5 and with an 8. So I think the best we can do is 40. Yeah, best we can do is 40. So we're going to multiply 5 times 8. We're going to multiply 9 times 8. So what we'll have is we'll have 9 times 8, we'll have 72 over 40 minus, and then we're going to have to do 8 times 5 and 5 times 5. So it'll be minus 25 over 40. And so the 40 and the 40, you don't subtract them at all. You'll just leave it as 40 on bottom. And then you do 72 minus 25. If you don't want to do that in your head, that's the kind of thing I'd be okay with you doing a calculator. But 72 minus 25, that's going to be 52 minus 5. That should come out to 47. And so we'd have 47 over 40. And if the problem doesn't specify whether it wants an improper or a mixed as the answer, just do whichever one you choose. I would choose that. So next up, 7 over 6 minus 5 over 6. No, wait, is that really the problem? Okay. You don't have to do anything about the 6 on the bottom, so leave that. And 7 minus 5. is going to be 2. And then 2/6 reduces to 1/3. And we are done. Okay, that was easy. All right, now this one. We have -1/3 plus 3/8. So 3 and 8, what do they have in common? They can both turn into 24. So we'll need to take the -1/3 and multiply the top and bottom by 8. So this will become -8/24. Let me make a comment on the negative sign on a fraction. Basically, the way a negative sign works on a fraction is you can apply that to the top or to the bottom. If you give top and bottom a negative, negative over negative cancels out, becomes positive. So if the fraction itself is negative, you pick which one to make negative. In this case, since we're only dealing with changing things on top, we'll put the negative sign up on the top. That's how we'll do it in this case. So anyways, so the 1/3 multiply the top and bottom by 8. We want 24. So the bottom number will be multiplying by 3. So it'll be plus, so 3 times 3 is 9. And then on bottom, it'll be 24. Okay, so -8 plus 9, that's just like doing 9 minus 8. So we come out to 1/24. Okay, there is your first 3. So let me erase and I'll write the next 3. Okay, so let's do, so number 4 is going to be -1 1/4 times 9. And then we have 5, -1/2 divided by 5/4. And then we have 6, -9/5 divided by 2. Okay. So what do we do about this? -1 1/4 times 9. So there's a couple of things we'll have to do. And so first, let's remember that if you have any number, it's technically that number over 1. So 9 is technically 9/1. And then what I'm going to do with this is I'm going to take 4 times 1 is just 4. And I'm going to add 4 to what's on top, which is the 1. So 1 4/5 is like having, it's -5/4. Okay, so again, 4 times 1 is 4. And then 4 plus 1 is 5. So we have -5/4 times 9/1. And is there anything that can be reduced? Doesn't look like it. So we end up with negative times a positive is just negative, and 5 times 4, so -45/4. And that's it. Okay, next one. -1/2 divided by 5/4. Well, when it's division, flip the number and back. So -1/2 times 4/5. Do we want to multiply and reduce at the end or reduce right now? I always would reduce right now. So 2 and 4. So it's remember, it's anything on top can reduce anything on bottom. So 2 divided by 2 becomes 1. 4 divided by 2 becomes 2. So -1 times 2 is -2. And then 1 times 5 is 5. So -2/5. All right, right here. -9/5 divided by 2. Let's make that a 2/1. And so we have -9/5 times 1/2. Remember, division just means flip the number and back and make it a multiplication. So we're going to have -9 times 1. So we'll have -9 on top. And 5 times 2, we'll have 10 on bottom. So -9/10. I hope you all are finding fractions easy. And I really hope there's a couple who were originally afraid of fractions that are saying, oh, fraction is actually kind of easy. This is not that bad. Why was I so bothered by this in high school? All right, so I'm sorry. Let me minimize what I have. Okay, so let me see if I can fit the next 4 on here. So all right. So I just did 1, 2, 3, 4, 5, 6. So I gotta do 7, 8, 9, 10. Okay, number 7. Oh, I think this is probably the hardest one on here. Number 7. Maybe. So yeah, it's definitely the hardest one on here. So negative 2 and 5/6 minus negative 1 and 1/4. Yeah, it's definitely the hardest one on there. 8. Negative 3 and 5/9 divided by 3. Okay. Number 9. 2 and 4/5 minus 5/8. And then 10, negative 2 and 2/3 times 4 and 1/10. All right. So let's get these last 4 done. So for this one right here, it's a subtraction or addition problem. So we can leave it mixed like this. Minus a negative is just going to become a positive. So what I teach pre-algebra, algebra 1 students to get used to doing is if you have a minus and negative, just connect them and make it into a plus, which I kind of tried to do there. But so really just to simplify this is going to be negative 2 and 5/6 plus 1 and 1/4. Okay, what's the bottom number? What do we want to do with that denominator? So that's a 6 and it's a 4. So those can meet at 12. So this is like having negative, I guess I'll continue over here. Let's see if I can. Yeah, there we go. Hold on, let me see if it helps me to shut this light off. Looks like there's a glare. Yeah, I think that helps. Okay. So negative 2 and 5/6. So the number that we can have in common with these is 12. So I'm trying to find a way to get where I'm not blocking, but I can write up here. Okay. So negative. So again, let me write it here. So we're going to multiply by 2, multiply by 2. So we'll have negative 2. And when we do 5 times 2, that'll be 10 over 12. Let me make sure you can see that okay. All right. And then plus 1, and then we have 1/4, and the bottom number we're working with is 12. So to turn 4 into 12, we'll multiply it by 3. So times 3 times 3. So we'll have 1 and 3 over 12. Okay. And so when you do negative 2 plus 1, think about like if you owed somebody $2 and they forgave one of those dollars, well, you would still be in the hole with $1. So it'll come out to negative 1 and then a negative 10 and a positive 3. If you owed somebody $10 and they forgave 3 of that, then it would still be at negative 7. So we end up with negative 1. Here, let me rewrite this. I didn't write my negative. So we'll have a negative 1 and then 7/12. So negative 1 and 7/12. Okay. So we take this, then minus a negative makes it a positive. And then we have 6 and 4 on bottom. We want to have 12 on bottom, which turns 5/6 into 10/12. The 1/4 turns into 3 over 12. And then it's a negative 2 and a positive 1, which makes a negative 1. And it's a negative 10 and a positive 3, which makes a negative 7. So negative 1 and 7/12 is what we get there. Okay, I do not think the other ones will take that much space or be nearly that difficult. Okay, so right here, let's make this over 1, and let's take this 9 times 3 is going to be 27, and then I add 27 to the 5, and 27 plus 5 is 32. So this is negative 32 over 9. And then because it's division, that means you need to flip that and make it multiplication. So times 1 over 3. Okay, now let's think about this. Does 9 go into 32 at all? No, it doesn't. Does 3 go into 32? No, it doesn't. So just multiply it across. And you do a negative times a positive. Negative times a positive just comes out to negative. So negative 32. And then 9 times 3 is 27. So negative 32 over 27. All right, let's look what we got right here. So 5 times 2. Actually, hold on. We're doing never. I'm sorry. We can just leave this. We don't need to deal with the mixed fraction, but we need the bottom number to be the same. So 5 and 8, they'll meet at 40. 40 is all we can do. So this 5 needs to multiplied by 8. 4 needs to be multiplied by 8. So we'll have 2, and we will have 8 times 4 is 32. And then we will have 5 times 8, which is 40, minus, and then in order to turn 8 into 40, you multiply by 5. So minus, we have a 40 on the bottom. And then on top, we'll have 5 times 5, so we'll have 25. And so it's 2 and 32 over 40 minus 25 over 40. And so we do 32 minus 25, and that becomes 7. So the 2 goes untouched, right? So it's I have 2 whole pies, and this guy didn't eat any whole pies. So how many whole pies do I still have? Well, I still have 2 whole pies. He didn't open any of the whole pies, but he went into the one that had 32 slices out of the 40. We took it and made 40 slices and had 32 left, and he only ate 25 of those. So 32 minus 25 gets me to 7 out of 40. And 7 over 40 can't be reduced. So 2 and 7/40. All right, last one. We're multiplying. So that means we can't have mixed fractions. So we're going to do 3 times 2 is 6. 6 plus 2 is going to be 8 over 3, and that's negative, times 10 times 4 is 40. 40 plus 1. So times 41 over 10. Okay. So yeah, 41 over 10. And let me make sure, give me 1 second. Let me double check, make sure I wrote this down correctly. I don't think there's anything wrong with the problem. I just want to make sure I wrote that down. Yeah, okay. And it's multiplication. All right. So before we multiply these, can anything get reduced here? Oh, I almost made a big mistake. If you're following along, you might be confused. Why is that a 6? This is what should have happened. 2 times 3 is 6, but then I do 6 plus 2. So 2 and 3 are 6, and then 6 plus 2. This right here should have been 8. Okay, I almost made a mistake there. That would have been confusing. So, and then we have 8 over 3 and 41 over 10. What can be reduced in here? Well, 2 goes into the 8 and the 10. So this becomes 2, and this becomes 5, because 2 goes into both of those. And 41, 3 doesn't go into that, 5 doesn't go into that. So that's it. So let's multiply across. So 2 times 41 is going to be 82. Oh, and the negative and positive. So final answer will be negative. And 2 times 41 is 82. And on bottom, 3 times 5 is 15. So negative 82 over 15. All right. So that's 10. Multiply, divide, add, subtract. With fraction problems, for those of you that hate fractions, I really do hope that now you don't think they're that bad. You might not necessarily enjoy them. They can get very annoying and tedious, but I'm hoping that you're not so confused by them for those of you who have messaged me saying that they were your biggest problem back when you took a lot of math. Okay, so that's it for this lesson. Go through these review questions. Remember that these are here at the end of every lesson. So if you are studying for the midterm or just as the class is going on, you want to look back and make sure that you remembered whatever was in that lesson, you could flip to this, go to the very end of the video, and look at this slide to see these 4 questions. If you know how to do these 4 questions, you pretty much are in good shape and you understand the lesson. I'm not going to go over these. These are just here for you to go back and look at whenever you feel like. All right, so let me go ahead and close in prayer, and then that will be it for the basic math part 2. Lord, I thank you for the group of students that's learning here. Lord, I thank you for this time. I thank you for Legacy, and I thank you for all the different staff that are volunteering their time at Legacy. I pray that this would not be a waste of anyone's time, Lord. I pray that this would not just be a requirement, that it wouldn't just be a box that's checked on some type of a transcript. But Lord, I pray that this would be useful information. I pray for those that have been intimidated by math. Lord, those that have always avoided math, those that have hated math. I just pray that this would take it and simplify it for them, Lord. God, I know that, there's a book of the Bible called Numbers. So God, I know you don't hate math. I know that you designed the world to work this way. It was within your mind that all this logic began. And so God, I pray that you would just give us a wisdom and ability to use the math that our ministry will call us to use, and let this class be a useful time of preparation, Lord. In Jesus' name I pray, amen. Amen. All right, so a couple of things before I close the video out. As I'm going through these, I'm literally just working these out on the spot as I go. I might make mistakes, okay? So if there's something that's really confusing where you're like, how did he get that? It's possible I made a mistake. Feel free to email me and reach out and be like, dude, did you mean to get that? Because this seems weird. We had one thing last lesson, something I made a mistake during a video. And so, yeah, just email if something seems off. It's possible I make mistakes as I go through these. So I want to bring that up. I want to bring up that make sure, even though discussion boards are due on even weeks, so like there's a discussion board due week 2. There's one that's due week 4, that's due week 6. Pay attention to them on the odd weeks, because what will happen is the discussion board that's due at the end of week 4 is designed to be started at the beginning of week 3. So you can put your first response within week 3 when it's due at the end of week 3. And then in the 4th week, which is where the discussion board will be written, you then have a full week to respond to other people, because it's a 2-part thing. So it's due week 4, meaning by the end of week 4, you've spent the first week putting a response to whatever question I put out. You've spent the second week responding to somebody else. So because it's a 2-week process, you need to be looking at it 2 weeks ahead of time. So when we get to week 6's discussion board, you will have answered that question during week 5. And then you respond to somebody else during week 6. And then week 6's discussion board is done. When we get to week 8, during week 7, you want to look at it, respond to other people. And then during week 8 is when you get those responses to other people done. So anyways, make sure that you're looking out for that. As always, if anybody has any questions, feel free to reach out through email. All right, thank you. I will see you guys next time. If I can find the button. Oh, there it is. All right, see you next time.